Alex Sparrow
from
UK Hempcrete.
and we're about to make some hempcrete.
So what we're going to need is about a bucket and a half of the dry hemp shiv, which is the aggregate in hempcrete, and then we're going to need some hempcrete binder, which is this stuff. There's 4 or 5 different kinds available. This is a natural hydraulic lime, a very strong hydraulic lime from the south of France, and it's so quick setting that we're going to have to put a retarder with it, and this is just food grade citric acid powder. So we're going to shake some of that in there and then just mix that in dry before we wet it up. Cement is basically lime with other minerals added to it. In fact, this is a very hydraulic lime which comes from a class called natural cements, and Portland cement, which is what you're talking about, is really just a formulated version of this.
But it uses a lot of energy.
It uses more energy in the production process, and because this is quite quick setting, but because Portland cement is even harder and stronger and quicker setting, it doesn't reabsorb very much of the CO2 that was given off when you burnt the lime. So it's in two senses. It's more energy intensive in the production process, and it doesn't reabsorb CO2 as it's setting. Whereas limes, to varying degrees, different kinds of limes will reabsorb CO2. So we're just going to mix equal quantities of the hempcrete binder and water so that we get a nice, we call it a slurry, and we make sure that the binder has got all of the water that it needs to take a set. And then you're going to help me by throwing the hemp in a little at a time while I mix it with a whisk. Put the water in. Lime, just watch out for the dust. So just mixing this first to like a smooth slurry. Keep going. That'll do. I'm going to compress like I'm making a snowball and compress a big ball of it. And then we're going to just make it as tight as we can. And then I'm just going to tap it. It should just break into a couple of pieces quite cleanly, like that.
Yeah.
So that shows us that the hempcrete's pulling together and it's just about ready to use. I would say that's slightly on the wet side, but it'll do for purposes of this. So this would be the structural timber frame of the building, which would all be constructed first, including the roof. And in this case, we've already got a skin of precast hempcrete blocks tied to the inside face of the wall. So that is also almost forming a permanent shuttering that we're going to cast our wet hempcrete against. And the reason for that is when you wet cast hempcrete on site, there's a drying time, about 6 to 8 weeks, which is not too bad in the summer months. But if you use precast hempcrete for the inside skin, then that means that as soon as the windows are in, you can move in, plaster the inside, start fitting it out, living in it. And the cast hempcrete that you've got to dry is now only 2/3 of the thickness, and it's on the outside of the building where the sun and the wind are going to help it dry. So we literally tipping in enough hempcrete for a sort of 4 to 6 inch layer at a time. And the reason for that is we don't want to have too much in, because when you compact it, it won't compact properly at the bottom. Just watch your eyes a minute. So all we're doing is spreading it out level in the void, like this, and then really just giving it a firm pat down with your hand. That's all the compaction that it needs. Because if you compress it too much, and you'll see videos on the internet of people with sticks banging it in, what you're doing then is you're pushing all the air out of it, which is where you get the insulation from. You're also making it more expensive because you're putting more material in to fill up the wall, and also because you crush all the holes and channels in the material, it takes longer for it to dry, because that's how the moisture moves out of the building. It's inflammable. So again, if you look on YouTube, you'll see videos of people with a blowtorch against a hempcrete block, dry hempcrete block, and you can leave the blowtorch on it for half an hour, and at the end of it you'll have a very small area of charred hempcrete that you can scratch away. But it doesn't catch fire, it doesn't really heat up, so if you put your hand on the back of that block after half an hour you don't feel any heat. And because there's no other chemical treatment, there's no sort of worry about toxicity and things off-gassing when in response to heat. When you're creating moisture inside by cooking or washing or breathing, instead of getting a sort of sheen of condensation on the wall, the hempcrete will absorb that moisture in, and then when the relative humidity drops inside, it releases it out again. So it's passively regulating the humidity inside the building. It's got quite an open structure of air inside the hempcrete, but also the microscopic pores, the cell structure of the hemp plant is lots of like little bubbles, and it's really hydrophilic. So because it's the stalk of the plant, and it's all about getting the moisture transfer up into this tall plant from the ground. So what it does naturally is it absorbs moisture in, which condenses in the cells of the hemp plant, and then just breathes out again. And that again is part of the dynamic thermal performance of the wall, because each time there's a state change where gas turns to water and then water turns back to water vapor, there's energy absorbed and given off in that state change. It's such a low-tech way of building, but it has this incredible performance. Because the hemp plant grows from, in this country, it grows to about 3 or 4 meters in 4 months. And it's a really tall, thin plant with all its leaves and branches at the top. So what it's doing is very rapidly, compared to other plants, absorbing atmospheric CO2 to create this carbon cellulose stem, which is the bit of the plant that we then chop up and use as an aggregate in buildings. So even after the production of the lime, which is relatively high embodied energy because it's burnt in a kiln, and the energy that transport and the energy we use on site, there's a net 50 kilograms of atmospheric CO2 sequestered in every square metre of hempcrete wall. The UK construction industry, according to the government's own figures, contributes 7% to the total UK GDP, and it contributes around 50% of our total carbon emissions as a country, and that's through energy in use in buildings, so heating systems being inefficient or building fabrics being poorly designed or constructed, but it's also in the embodied carbon in the materials that we use to build with, which are quite often high intensive carbon processes. So we have to change.
Absolutely.
And hempcrete provides a solution to all of that, not only the high performance of the buildings, but also to the better than zero embodied carbon in the buildings. So yeah, the main barriers to scale up are nothing to do with the hemp really, they're more to do with sort of certification and insurance of building products. So we're now at the stage where we've got thousands of hempcrete homes around the UK, some new build, some sort of hempcrete housing estates dotted here and there. Lots of homes where people have built hempcrete extensions, or they've used hempcrete to add retrofit insulation to existing masonry buildings. And we've also got, we must be into the hundreds of hempcrete commercial buildings around the UK. So it is there. It's just that, as my company is a fairly small company, our challenge is growing to meet demand, not looking for the demand. Does that make sense?